Hello everyone, this is Ashwin. I'm just going to discuss on the final report for ADTA 5240. This is the harvesting, storing and retrieving data. On going back to the first section is how to deploy a big data technology in a firm. Like comparatively, like if you consider it's going to be a a big firm where the student is going to analyze and suggest his or her options to the organization to incorporate the enterprise solution level big data technology. So basically big data, what's big data? Big data, it's like right now it's hot in the market because of the faster performance and better data processing when compared to the traditional system. Like organizations, they focus on a term called MROI. It's going to be marketing return on investment, because that's going to be a major key in deriving the big data technology. Like as we know, like changing a platform to platform, migrating from one system to another system, it's going to be a tough call. Basically, me in mortgage industry, it's going to be like a tough call from moving from environment to environment. In that place, we might need to give specifics why we are choosing big data technology over other traditional methods. So we will be going through all the different steps, like different various technology, and what's the difference between the big data technology and what's the difference between the traditional, how it varies and what varies. So that's what we are going to check over here.
The evolution of big data is influenced by the key points which are going to be discussed below. The first one is going to be the assessments based upon the data quality. Data quality. So we just are more concerned on the current world. We just more concerned on data quality, how data is stored, how data is going to be retrieved, how fast data is going to be retrieved. So for all these things, data quality is much more a key essential part. It plays an important role because the data is coming in various formats, different data, wide range of data, different formats. So we need to make sure like all the data is being cleansed, it's being of enough data quality, and that's where the first example which I mentioned here, better assessment of data quality. Here I have given the example for a student who doesn't have enough credit score, but in order to check that one, he doesn't have a car loan, he doesn't use the credit cards, or he is not a salary employee, but he has a bank account, he pays his cell phone bills, and he uses the mobile payment apps like Venmo and all those stuffs. So in that way we can obtain all the activities which the student has made to make sure all the different formats of data are stored in a single format in a single place called maybe a big data technology I can use here as data lake. So all these different formats is used and stored in a single platform, and from there like we can process it using the various different technologies which cannot be done on the traditional methods because adaptation for various formats of the file, it's not possible. Like if it's not in the sense like that in the traditional way the handling the formatted files are much limited. They have certain formats which can be processed, and the raw files cannot be congested into the data warehouse as easily as it could, and the proper process needs to be defined for that. Whereas in the big data world we can process numerous formats of data into the warehouse. And going back to the second point, it's going to be the maximizing of the servicing returns. Like servicing is one which is concerned with respect to mortgage firm where the organization is going towards the big data world. Like it's going to be a volume driven and low margin business because the volume is going to be more. Because if for example integrate the voice recording service, if a customer calls and if he wants to call for bankruptcy or if he wants for foreclosure, he just wants to go in different panel and different options, different menu. So each data, each call, each recording what he speaks, the customer speaks, is recorded into the database. So
all these maximum, this is going to be the servicing stuff we do apparently to enhance the customer experience. So this one will for in this example I have just given like example like where the customer can be identified by by borrower name, and probably can just be alerted for missing payments or how to outreach for his delinquencies. So this will be like how we can you can ensure like all the payments are made successful and most effective way to track the borrowers in such a way that the enterprise is getting profited by. The third is going to be the efficiency, increasing the efficiency stuff. Increasing efficiency is going to be like the speed and efficiency in closing a loan uh, plays a basic role in increasing the efficiency of the process. Like the underwriters or the agents can focus more on the customers rather than focus on the technology, how they are going to get the results, and how accurate the results are going to be from the system, directly from the system. That's going to be less concern for the agent, for the underwriting agents. For example, if you can consider the underwriting agent for approving the loan or closing the loan, it will be easier for them to gather the data if it's going to be more efficient. If not, they need to analyze the data first, then check, do the pre-calculate the stuff, and then do all the manual calculation. So if the data is proper, so we can, and if the data is efficient enough, using the latest technology, which can be done using the big data, that would be great for the organization, which in turn gives a better turnover. These are the basic points which I wanted to tell with respect to the big data. The first point is going to be the volume. So the volume in the sense like how the data is going to be transmitted from machine to machine, in the sense like large amount of information will be captured. So this is the first point. The second point would be the velocity, like how much data it's flowing. Like if it's going to be real-time analytics, for example, I can just tell you a TV remote information. Like for Spectrum or AT&T systems, they usually go with this is going to be on the media domain. Like if they want to calculate the audience measurement, they want to note and identify each and every individual click in the remote. Like if a customer has five separate of their five TV sets at home, and he has five set-top boxes, then each it has five remotes. So each and every click on the remote counts as a record. So it needs to be come on a real-time basis. So if that's the case, it's going to be petabytes of data like on a single day. So the volume is more, so and the data flow on velocity also matters, because the rate in which the amount of records are flowing into the warehouse depends on the processing power of the source. Like if the system is not able to handle that much amount of data, then at a constant velocity, then it's going to be a problem, because it will result in data congestion. And the third one is going to be the variety of data, like different format of data. As I told before, the different format of data can be used here, not just a specific set of formats which we use in traditional systems. This can be unlike that. We can just use various systems like Avro, Parquet, and all those different way of formats. Like it won't be a human readable format, but it can store n number of spaces. So that should not be a problem while retrieving the data. The third last one most of it going to be like variability, like different data variation, whether it's going to be hit the peak or it's going to get low. This will be evaluated, like if for example, if in the stock market world, like when the market opens, we are expecting a peak performance for the first 5 minutes, and after that it's going to be, if the company performance like if they announce any results, then it's going to be a peak performance, or else it could be based upon the market trend, it can be a peak, or like it can be in the middle. So this where variability matters, like this trend, and this would be used for trend analysis purpose. So this will be very challenging when we deal with the structured data. So unstructured data, it's like we can handle it, like we can just load in the data lake, and from there we can just use a different format to read this data. That will be update faster enough to update it. The one more stuff is going to be the value. The value is like how much data value it is providing. Like, yeah, we can have n number of data sets, but not all the data sets provides a value to us, to the business. So what value, like KPI, what KPI, key performance indicators, can be got out of this data which we are providing. So those can be measured. The almost stuff is going to be the veracity. Veracity is the data quality, like as I told before, the based upon the number of inputs, number of entities, like based on number of subject areas, like how much right data and efficient data is available. That's called as veracity. And validity, like if it's going to be a valid data or it's going to be invalid data with a improper format. So like improper format in the sense, like we can't read that data. Some case, like if consider traditional data tools, like if the data format is not proper, they will load it as null or they will load it as spaces, so the actual data is missed. So in this case, the unstructured data, it's going to be stored as a flat file. So all the data will be available on the data store or data lake probably. And once if we notice, like if we are not able to figure out the source for that one, we can do some transformation, populate the data over there. And this would be a quicker process when in big data when compared to the traditional processing. So it was mentioned over here. The last one, the last before is going to be virtualization. The data visualization is going to be like an efficient process in projecting the results to the business, to the end users, to the customers, to the stock markets. Like this plays an important role for the business. So virtualization is more ability to visualize them in a better picture, like a graph, like a machine language, like machine learning technology, like a Tableau, like a Power BI, like different various varieties of data will be used for visualizing the data. Um, so this is the main challenges. So this these are the differences in this stuff. We can figure out the big data challenges between the unstructured and the structured data. So based upon different various public storages, machine data, sensor data, and all those things, volume. So for example, the log data, it's like complexity is, the velocity is more, variety is more, and the volume was also more. But the complexity is like it's moderate over here. So this matters. If so to handle this part, I guess machine learning stuff, like more kind of ML language, like that big data plays a big role there, like Google Cloud Platform, like TensorFlow or Keras can be used to obtain those information. Here we have the sensor data. Sensor data also we have different neural networks, sensory information which can be derived out of the Google Cloud platform using the various libraries. So these are efficient stuff which can be done on a cloud platform using the various big data technology. The initial expense is more. We agree that the initial expense is more for deploying the big data technology, but this is going to be a investment which is going to be a long time run. And if the environment is friendly, like if the environment is properly set up and all the infrastructure is available, then the organization will be having enough turnover, and the return on, as I told before, the return on investment would be a much gain process towards doing those. So let me go over some additional big data stuff here. So these are the example for the traditional analytics and the big data analytics, where the focus is more about descriptive analytics and diagnostics analytics in traditional, where big data is going to be more kind of a SaaS programming, or it's more kind of a predictive analysis, like we are going to predict them, we are going to predict, train the model. We are, if this how this traditional BI requires a human power, this is going to be a machine language, and we are going to train the model using neural networks and all the latest technologies. In that way, we can reduce the dependency, the labor costs, and all those things. The data sets is like we have limited data sets, and we require a cleansed and wrangled data set, and a simpler model for deriving the traditional analytics stuff. Yes, a data set in the sense like to obtain the traditional analytics BI stuff, we might need to have a proper data model, a logical, physical, and the conceptual. First, starting with the conceptual, then logical, then the physical data model. But when it comes to the big data world, it occupies various scales. It doesn't have a definite set of data model stuff, because it contains like multiple data types, and it's like a complex data model. So deriving a data model from different data sources, like it has n number of data sources in a data lake, where we have different formats of data as raw files in the big data analytics. That's what we have mentioned here. It's going to be like a raw files. So that makes a difference between the traditional analytics and the big data analytics. And if you see here, this is going to be the next difference between the relational and the non-relational. Like it occupies like a large accommodates like a large volume of data. Yes, for extended relational model. So the non-relational model would perform better to store large volumes of data. Then the self-reference and the ad hoc reporting. The ad hoc reporting would be, I would say, more easier in the traditional way, but it's less compatible with the non-relation system because of data formats. Because ad hoc, it's like people can go and query it from a traditional database where they have the relationship in place, but for the non-relational stuff, it's like a raw file, like it's a different format, so it's not a user friendly, but this is of a different case. And if the third and fourth point is like unstructured data processing and high data model extensibility. This is supported in the non-relational, whereas in traditional this is not possible, because in traditional we need to go with a certain model limits, and it needs to adhere to the normalization form, whether it's going to be 2NF, 3NF, or it's going to be a star schema, or if it's going to be a snowflake schema. It's going to be adjusted towards the traditional data model, whereas in a non-relational system the data is unstructured, so this problem doesn't have a call over here. And the data quality is comparatively more, and the security also is more when compared to the non-relational, because data quality is more, because it's user friendly and people can analyze more data to it, and consistency wise they can govern, like they can have a key constraints in a table, whereas in a non-relational stuff it's going to be like a raw format data. So it's yeah, it has pros and cons. This slide is to tell you the pros and cons of relational versus the non-relational. But in case of latency, near real time is possible in non-relational, whereas extended relational is possible, but it's expensive. The When the cost is more than the it can be done as a real time purpose, but with less expensive, this is the best solution on the non-relational stuff. And considering the fact for more performance wise, operational cost, the low it's less in non-relational when compared to relational systems. And the skills availability, the resources, what you mean to say is like the created skills, like the talent, it's more vast in the extended relay model, like where we have all the traditional systems like Teradata, Informatica, SQL Server, Oracle, all those things comes under the normal SQL traditional process, whereas the big data, Hive, Spark, Google Cloud Platform, these are the new evolving technologies. So apparently the skill set is very rare and it's tough to find out in the market. So that's all about the comparison between the traditional and the non-traditional. Here, I just explained you about some examples on the structured storage, which is going to be a traditional SQL data. Like this can be a comma separated file. So here it's going to be a comma separated, commonly used file. Whereas the below example here, it's going to be in unstructured storage. It's unstructured storage is going to be a uh, single line, like data. It's going to be like on a raw file. So this would be considered as a single line, a single request. It can be like a different format, like JSON format or a Avro format or a Parquet format. So people can, if it's going to be encoded, then people can't read this when you store it in a SFTP or mount it to a mount path location. Then people can't read this unstructured until and unless it's loaded into a table or a cloud table. And these are some what improvements can we make in using the big data stuff. Like this example is basically for document classification while retrieving the loan documents for a company, for example. So what stuffs can be done, like data extraction in the sense like speed, accuracy, recording of each stamp identification. OCR is like optical recording stuff. This is like will record or capture the images based upon the patterns. So each in a, when a customer letter is sent to a customer, and a system needs to read this one, instead of updating into a manual process, this OCR technology will make sure like optical recognition, it can capture the images, it can capture the symbols, it can capture the signatures, and it can convert into files, and it can, instead of we manually scanning a human scanning manually, this can automatically scan it, store it in the Google cluster, and from there it can send out to different messages. So this is what can are much more used in the day-to-day big data world. And big data like business improvements is like missing documents identification and duplicate document identification, like auto doc, as I said, like it uses the auto document packing, and provides a tag name like packing, and it's going to be a real-time document classification. So this one is the operational efficiency. Operational efficiency is going to be like the decreased cycle time and the processing per person based upon the documents, how much our the agent reads it. So these are like different options available. And this is the global cloud platform document where whatever I told you, it's like different technologies, how the image is going to be stored. It's going to be on Google Cloud Platform, like but how the image is getting stored, how the image is getting scanned, and how the app engine works. And based, they are using some neural networks here, and based upon that, based the output of the neural networks, they are training the machine language this thing, machine learning tools. They are training a model, and that model is being used instead of a manual agent in place. So this is the architecture for that one. And if you see here, this is going to be a big data structured. In case of traditional, it's going to be only the structured. Now it has structured, semi-structured, and unstructured. It uses like ETL API, goes into the HDFS, then uses the high map reduce and goes back to the web browser to the agents. So here is a different data sources, as I told you, like all the real-time ingestion and messaging happens here. Structured data, unstructured data, which stores into a central data catalog, and from there it can uses the API and the end user application, and the business users can use that. And that's all about in the part one. Now we can go to the part two. part two is going to be the Apache Hadoop with Hive. So this is basically a company where it runs in four regions: East, West, Central, and South. So and it has major segments like consumer, corporate, and home office. Here we are going to explore this with a Hive. So in the Google Cloud GCP platform, I'm creating a bucket called Ashwin Hadoop bucket, and from there we can see the Ashwin Hadoop bucket, and the compute engine and the data proc API is enabled. And once that's enabled, we can just create this cluster, and the cluster is created and it's active, which is showing as a green symbol out here. And once that's done, we are just going out here, creating a new folder called data in the um, file, and from here we are going to take into the SSH command path. From the SSH command path, we can go and check whether the files exist or not. So the first time the files won't be existing, so we are creating a file folder called data, and inside data we are putting in the file, and we are connecting to the Hive beeline over here. And when you do a show table, there are zero tables which has been present out there. And after that, like we are just creating a sales input file is going to be sales record. So we are just creating a sales record table out here. And the sales record table, we are just creating an external table, and I'm doing a limit. First limit one is going to tell me all the headers of the file. Limit 10 is going to be telling the first 10 records of the file. And then what I'm doing is like I'm just creating a table with comma separated field and all the column names in between. And here is the top five states which was requested, for which has most number of customers. Here you can see California, New York, and Tokyo, Pennsylvania, Texas, Pennsylvania, and Washington ranks the top five states, and the top 10 zip codes are given over here. The first part is like zip codes with the total sales, and the profit also is coming. Like the second one is the actual question which was there, like the postal top 10 postal codes with top sales. And the first one you can see like postal codes with respect to sales and profit, even though you can see like there was a postal zip code as for 32216, for example. It has given 37057, but the profit is like 2550. So from this the company can infer like they need to modify something over here, because the sales is more but the profit is less. So the company needs to find out like what's the reason behind this, like based upon certain proprietary parameters. The similar thing we are doing it in the hand, which Apache Spark. So here I'm just connecting the part three is like I'm just connecting the Spark SQL, and in the Spark SQL it's going to use the same meta store. So when you see the same meta store, if you go and check the tables, the table already exists because Hive and Spark uses the same meta store. So after that, we are just querying the table, and we are getting the first top five states where the company has most number of customers, and the top 10 zip codes where the customer has more sale amount. Okay, now we are going to go for part 4. The part 4 is like to compare the performance between the Hive, MapReduce, and the Spark SQL. Let me start with the Hive and MapReduce. So Hive, what's Hive? So Hive basically is allows to read, write, and execute large data sets in a distributed MPP system. So it's basically a massively multi-parallel processing system. So it was built on top of Hadoop HDFS, and it has a very wide range of features as well. So because unlike like other big data stuff like MapReduce stuff, Hive is like requires a basic traditional SQL like language. Like if you know the basic SQL, then it will be easy for you to access Hive because it's driven based upon a SQL. So here we are just using Hive SQLs such as ETL reporting, data analysis, and all those things can be done in Hive with normal SQL. If the analyst or if a data scientist knows just a SQL, that will be more than enough to use get used into a Hive. And as to files, access to the files which are directly stored in Apache SDFS or HBase. So it can be easily be accessible to the HDF files which is already being available on the HDFS storage device. And it's like a second sub-second query retrieval via LLAP, Apache and Apache Slider. This is like a subquery, subsequent query retrieval. That means like the query performance based query within a query, right? So it's like a subquery kind of a stuff like it's more fast when compared to and when compared with other systems, and it uses the yarn also. Yarn is a processing engine, so it takes uses all those components in from Hadoop to make sure that it has much more faster retrieval of data. And the third one is it supports variety of data format, as we know. Here I am just telling about the huge data sets, like because it supports various huge processing data sets which can be used as multi-processing system. And the second point is going to be it's an economical solution, but it's not like performance intensive one. Like it's not that much great on performance when compared to Spark. So here on the Spark is going to be like it's scalable, and it's basically used for used within the Java, Scala, Python, or R. It supports a Spark SQL. Basically, Sparks run with a different kind of API. Like it has a SQL API, it has a Dataproc API, and it has quite a lot of 3 or 4 APIs, which will be explained, which was explained in the Spark architecture. Yeah, this is like Spark SQL, it's more stable, and it's more you can just operate in a more near real time. The NRT, people used to say as NRT, it's like a near real time where it's more faster because of the various partitions over here available. If you see here Sparks, if you see here the Spark SQL, right? So this is what the same query which was run in the Hive was given for 14.865, whereas the same query which was running in the Spark, which was retrieved at 8.325. This tells like the amount of parallelism. Like it's a MPP system as well, but this the amount of parallel processing that is done at the CPU level. So it operates at a specific degree of parallelism. So this would be have 2 or 3 tasks per CPU, and that will increase the amount of data which is getting processed. So that's called as the parallelism, and that makes sure like better performance. And data bucketing. If you see a data bucketing is like data is split in Spark based upon the partition which you do. So it is basically on if you give more indexes like the data is partitioned and then stored. So while retrieving, it will hit directly the partition and data is retrieved from there. So this would improve the performance and stability because the data is constantly getting partitioned and the partition data is retrieved. So data retrieval is much more faster when compared to the Hive systems over here. And yeah, it's like it uses a distributed query engine with the ODBC and JDBC systems. So the end user can interact with, since it is running with the JDBC and ODBC, the end user can directly interact with the Spark SQL, and they don't want to write any code. It's just written using interaction using the Spark SQL API, and using that one, we can just extract the output which is required. So this is the advantages of Spark over Hive. The main thing is going to be the fast data processing, where it uses the CPU and the RAM. So it's much more faster when compared to MapReduce and Hadoop. And iterative processing, it can do my task again and again and again. And that's what this is mainly used for near real time, because near real time people expect data to be there in every 60 seconds, and this helps the purpose. The third thing is like the next one was really the graph processing. This one, like Spark used in different various graph processing for machine learning purpose, like the various graph processing from where you can use for a visualization purpose. And it has Spark has various languages API, and this is like mlib is like the matplotlib, where you can do some basic like machine learning stuff to provide it. It's blocks of algorithms run in memory and joining data sets. Due to the speed, it can create all the data sets, combine it much faster. And since data is already partitioned, there is no much shuffling or sorting would be needed. So that's all about the differences and the performance between the Spark, Hive, and